here are your notes for target 4. So target 4 actually has two kind of components to it, two methods that we're going to talk about. So it's only one target, but it feels a little bit like two because of the two different methods. So ultimately what's happening in target 4 is we're solving exponential equations. And so if you look at these first two problems that we can see, you can see that you have x in the exponent. And that's what makes these exponential equations, and that's how you can identify those really easily. In order to solve, you have two methods that you can use. Method 1 does not always work, and method 2 will usually work. So you do need to know how to do both methods. So starting with method 1, which is called equating the exponents. And I'm actually going to call this something else as well. I'm going to call this same bases. So when I say the word bases, what I'm talking about is the number being raised to the exponent. So on problem A, the bases are 4 and 1/2 to start off with. So you have 4 over here, and you have 1/2 over here. And so what our goal is to rewrite those numbers so they actually have the same base. So this takes a little bit of practice, and it's kind of like whenever we were doing factoring, and it just takes some time to get used to it, the number sense of it. So starting off with 4. 4 can be written as 2 squared. 1/2 can be written as 2 to the negative first. So what I've done here is I've rewritten 4 as 2 squared and 1/2 as 2 to the negative 1. I haven't changed the meaning of either of those numbers, but they both have the same base. They both have the same base of 2. And that's your goal here. Now I'm going to go back to the problem because I haven't written everything that was there. So on A, it said 4 to the x. So now I have 2 squared to the x and 1/2 to the x minus 3. So all I'm doing in this first step is rewriting those bases so that they're the same number. Then moving forward, what we're going to do is actually ignore those same bases. So I'm going to ignore the 2's. And I'm going to use my properties of exponents to combine these two exponents. So that exponent would be 2x. I would multiply those exponents equals, I would have to multiply these exponents together as well, negative x plus 3. So notice what I did there is I ignored the 2's that I highlighted, and I just set the exponents equal to each other. So once you get the same base, you can actually ignore those bases. And then this is a really easy equation to solve. I'm going to add x over. So now I have 3x equals 3. And if I divide by 3, I get x equals 1. So let's see how that works over here on B. So let's try that process again here. And this might be one of those sets of notes that you actually want to go back and watch a couple different times just to make sure you understand. So on B, you have 9 to the 2x, so the base here is 9, and then equals 27 to the x minus 1, so the base over here is 27. So my first goal is to get those two bases the same. 9 can be written as 3 to the 3rd power. And 27 can be, oh wait, hold on, sorry. I did that backwards. 9 can be rewritten as 3 squared. And 27 can be rewritten as 3 to the 3rd. So now I've rewritten this so the bases are the same, 3 and 3. And I haven't changed the numbers. 9 is still 3 squared, 27 is still 3 to the 3rd. So all I have to do in order to continue is to make sure I don't leave out those original exponents. This was 9 to the 2x equals 27 to the x minus 1. And once you have the bases the same, then you can actually ignore the bases and just use your properties of exponents. So 2 times 2x is 4x equals, I have to distribute the 3 over here, so that'd be 3x minus 3. And then solving, I'm going to subtract 3x. So I get 1x equals negative 3 for my final answer. So the hard part in this target, or in this method specifically, is that first step, writing it in the same base. All right, on C we have 100 and 1,000. So when I think about writing this in the same base, 10 kind of goes off in my head as a good base to use. So 100 can be rewritten as 10 squared. 1,000 can be rewritten as 10 to the third power. So I haven't changed those numbers, but they do have the same base now. Don't lose your original exponents. And then once you find those same bases, so again, that step I just did is the most difficult, then use your properties of exponents to combine them, and you can actually ignore the tens. So 2 times 7x would be 14x. 2 times 1 is 2. And then if I distribute the 3, that would be 9x minus 6. Continuing to solve, I'm going to subtract 9x over here. So that would leave me with 5x plus 2 equals negative 6. I'm going to subtract 2. So I get 5x equals negative 8. And if I divide by 5 on both sides, I get x equals negative 8 fifths. So as we've kind of gotten used to in second semester, our answers aren't always pretty, and that is totally okay. Don't feel like you did anything wrong. All right, so moving on to D, the last example of this first method. 81 and 1/3. We have to write those in the same base. I'm recognizing that 81 is the same as 3 to the 4th power. And the reason that that's helpful is that 1/3 is the reciprocal of 3. So I could write that as 3 to the negative 1st. They're both in base 3, but I haven't changed those original numbers. Carry down your original exponent, so 3 minus x on this side, 5x minus 6 on this side. And then you're going to combine your exponents, so I'm going to distribute both of them, so I ignore the 3's. This is 12 minus 4x equals negative 5x plus 6. If I distribute that negative 1, I'm going to choose to add 5x over here. So then that would be 12, and that would be plus x equals 6. You can subtract 12, and we get x equals negative 6. Okay, so this is the first method we have to solve our exponential equation. So the tricky thing is that you've got to look at the bases on both sides and rewrite them so that they are the same base. After that, going from, for example, this step to this step, all you look at are the exponents. You actually ignore the bases from there. Now, if we look at the back side of your notes, the problem is that we can't always write two numbers in the same base. So if you look at example E, 4 and 11, it's impossible for you to write them in the same base. So what we're actually going to do is we are going to use target 3, which was taking your exponential equations and putting them in logarithmic form. And we're going to do that again here. So as a reminder, in order to put an exponential equation in logarithmic form, you do what's called a loop and scoop. And so that would be log base 4 of 11 equals x. Now remember, when we solve for equations, we solve for x, and now we've gotten x by itself. So this is really helpful. Hopefully that looks familiar from target 3 our last day of notes. Now from here, it takes some calculator work. So we actually have to type log base 4 of 11 into your calculator. But most calculators only have a button that just says log. So the way that we have to type this in is you use that log button and you put 11 in the numerator, and then you use the log button again and put 4 in the denominator. So you do the last number over the first number. And that's just a way for us to actually type this into our calculator. Nothing more than that. So when I actually type this in, I do log, find that log button, and then 11, I close the parentheses, then I hit divided by log of 4, close the parentheses. And it's going to give me a decimal. It's 1 point. That would be 730 if I round to 3 places. And just know on these problems, you're usually going to get a crazy decimal like that. You can always check your work because I know these numbers are kind of uncomfortable. So if I go back to the original problem and I do 4 to the 1.730 in my calculator, I get 11.004, which is good because remember I rounded that x value, but you can always plug it in to check your work if you don't feel comfortable with it. So same idea here on F, just different numbers. So we're going to loop and scoop. Log base 2 of 5 equals x. And then to type this into our calculator, we do log of the last number divided by log of the first number. So going to the calculator, I do log of 5, close the parentheses, divided by log of 2. And I get 2.322 if I round. And again, if you wanted to plug that in to check your work, you totally could. So down here on G, same idea. I know we have a 9x in the exponent, but we'll see how to deal with that. So loop and scoop. So we have log base 7 of 15 equals 9x. I'm going to ignore that 9x for a second because I've got to figure out what this number is. So I do log of 15 over log of 7. That still equals 9x. So I'm going to type that into my calculator. Log of 15 divided by log of 7. And that gives me, if I round to 3 places, that would be 1.392. And remember that still equals 9x. So the last step here is I actually have to divide both sides by 9. I didn't have to do that on the previous 2 problems. So now I get 0.155 equals x. So just a little bit more solving there on the back end. All right, H looks kind of crazy. It's got a lot going on, so I want to talk about a couple of different things. So the first thing I want to talk about is E. E is actually not an exponent. E is a number. E is equal to 2 point, hold on, I'm going to type it into my calculator. It's equal to 2.718. So it's kind of like pi. And the fact when we see pi, we know that's 3.14. Those are just numbers that are represented by a variable, essentially. So that's the first thing I wanted to mention is E is a number. And the other thing I wanted to mention is there's a lot going on in this problem. So before we loop and scoop, we actually have to get rid of everything that's not being raised to an exponent. So our first step is going to be to add 7. So we have 4 times e to the negative 0.3x equals 20 now. And then I also have to divide by that 4 before I loop and scoop. So I have e to the negative 0.3x equals 5. Now our problem looks very similar to our 3 previous problems. And now once you have whatever's being raised to the exponent by itself, you can loop and scoop. Log base e of 5 equals negative 0.3x. Okay, last thing that's kind of crazy on this problem is log base e is actually the same thing as the natural log, which is ln. The reason that that's helpful is on your calculator, you actually have an ln, a natural log button. So look for that real quick. It's usually really close to the log button. So I'm going to hit ln 5. And the natural log of 5 is 1.609. That's equal to negative 0.3x. And so now I have to divide by negative 0.3 to get x by itself. I use my calculator. And I'm getting a final answer of negative 5.365 for x. So I know that last one was kind of crazy because it had a bunch of stuff on the outside. You had this e. I think the problems on your homework are easier than this. The other thing I want to mention before I let you guys go is we will always tell you like when to use method 2 versus method 1. So just make sure you know what each of those methods look like and how they are the same and also different.